High above us in the vast expanse of space, a silent threat looms, often unnoticed by those of us on Earth. It's not aliens or asteroids, but something entirely of our own making, space debris, a byproduct of our ventures into the cosmos. This ever-growing cloud of junk, remnants of past and present space endeavors, poses a significant danger to active satellites, spacecraft, and future space exploration. Each piece, no matter how small, adds to the peril. Space debris consists of defunct satellites, spent rocket stages, and fragments from collisions. These remnants are scattered across various orbits, creating a hazardous environment. These objects, traveling at incredibly high speeds, can cause catastrophic damage upon impact with operational spacecraft. The sheer velocity amplifies the potential for destruction. Imagine a tiny paint chip, traveling at thousands of miles per hour, smashing into a satellite. The impact, though seemingly minor, can have major repercussions. The consequences can be devastating, disrupting communication networks, GPS systems, and scientific research. A single collision can set off a chain reaction, worsening the debris problem. As we continue to rely more heavily on space-based technologies, the need to address the growing problem of space debris becomes increasingly critical. Our daily lives depend on these technologies more than we realize. Our future in space depends on it. Without effective measures, the dream of exploring and utilizing space could be jeopardized. Space debris is not a natural phenomenon. It is a byproduct of our ventures beyond Earth's atmosphere. It's a direct result of human activities in space, from the earliest missions to the latest satellite launches. This debris is a testament to our ambition and, unfortunately, our negligence. Each piece tells a story of human exploration and the unintended consequences that follow. Every launch, every mission, leaves behind a trail of debris, adding to the growing junkyard in orbit. This accumulation is not just a minor inconvenience, it poses serious risks. The most significant contributors to space debris are defunct satellites. These silent sentinels, once vital for communication and research, now drift aimlessly. These are satellites that have reached the end of their operational life and are no longer functional. They remain in orbit, serving as relics of past missions. They remain in orbit, adding to the clutter and increasing the risk of collisions. Each collision can create thousands of new debris fragments, compounding the problem. Spent rocket stages, discarded after propelling payloads into space, constitute another major source of debris. These remnants of our technological prowess are now hazards. These large metallic structures pose a significant threat due to their size and mass. Their presence in orbit is a constant reminder of the need for better space management. Finally, collisions between existing debris objects generate countless smaller fragments, each one a potential projectile capable of causing damage. These fragments can travel at high speeds, making them dangerous. This cascading effect, known as the Kessler syndrome, is a growing concern within the space community. If left unchecked, it could render certain orbits unusable for future missions. The amount of space debris is not static. It's constantly increasing as we launch more satellites and conduct more missions in space. This exponential growth of space activities, while necessary for technological advancement, exacerbates the debris problem. Imagine a highway with no rules where cars are abandoned after use, their parts scattered across the road. That's what's happening in low Earth orbit, the region where most satellites operate. This growing cloud of debris poses a significant threat to active satellites and spacecraft. Even a small piece of debris can cause significant damage, potentially crippling or destroying a multi-million-dollar satellite. The consequences of such collisions can be far-reaching, affecting communication, navigation, weather forecasting, and scientific research here on Earth. The Kessler syndrome, named after NASA scientist Donald J. Kessler, describes a scenario where the density of objects in low Earth orbit becomes so high that collisions between debris objects become increasingly likely. These collisions, in turn, generate more debris, leading to a runaway chain reaction. Imagine a domino effect, but instead of dominoes falling, it's pieces of metal colliding at incredibly high speeds. This cascading effect could create a debris belt around Earth, making space exploration and satellite operations extremely hazardous, if not impossible. The Kessler syndrome is not a theoretical concept, it's a very real threat that scientists and engineers are working hard to prevent. The consequences of inaction in the face of the growing space debris problem are significant and far-reaching. Collisions with debris can damage or destroy operational satellites, leading to disruptions in vital services we rely on every day. Communication networks, GPS systems, weather forecasting, and scientific research all depend on satellites operating safely in orbit. If these satellites are damaged or destroyed by debris, the impacts will be felt globally. The economic costs of space debris are also substantial. Replacing damaged or destroyed satellites is an expensive endeavor. Moreover, the loss of data and services due to debris impacts can have significant economic implications for various industries. Recognizing the growing threat of space debris, the international community has taken steps to mitigate the problem. These efforts focus on two main areas: reducing the creation of new debris and removing existing debris from orbit. International guidelines and agreements, such as the UN Guidelines for the Long-Term Sustainability of Outer Space Activities, promote responsible space practices. These guidelines encourage countries and space agencies to minimize debris generation during space missions. Design changes in spacecraft and launch vehicles, including the use of debris shields and tethers, aim to reduce the amount of debris created during normal operations and at the end of a mission's life. While preventing the creation of new debris is crucial, addressing the existing debris population is equally important. This is where active debris removal, or ADR, comes in. ADR technologies aim to capture and remove large pieces of debris from orbit. Several innovative concepts are being explored, including space-based tugs that can grapple and deorbit debris, robotic arms that can capture and secure debris, and even ground-based lasers that can nudge debris into a lower orbit, causing it to burn up in the atmosphere. These technologies are still in the early stages of development, but they hold promise for cleaning up our act in space and preventing the Kessler syndrome from becoming a reality. Sustainable space practices. Designing for demise. Another crucial aspect of mitigating space debris is designing spacecraft and missions with the end in mind. This means incorporating features that minimize debris generation during and after a mission's operational life. One such practice is passivation, which involves deactivating a spacecraft's systems and venting any remaining fuel at the end of its mission. This reduces the risk of explosions or collisions that could generate debris. Another practice is designing spacecraft for demise, which means ensuring they burn up completely upon re-entry into Earth's atmosphere, leaving no hazardous debris behind. This can be achieved through the use of specific materials and design configurations. International cooperation, a shared responsibility. Space debris is not a problem for any one nation to solve alone. It's a global challenge that requires international cooperation and collaboration. The space environment is a shared resource, and all nations have a responsibility to protect it. Treaties and agreements, such as the Outer Space Treaty of 1967, provide a framework for international cooperation in space. However, more specific and enforceable agreements are needed to address the growing threat of space debris. Data sharing and coordination among space agencies are crucial for tracking debris, assessing risks, and developing effective mitigation strategies. By working together, we can ensure the long-term sustainability of space activities for generations to come. The future of space exploration, a call for stewardship. As we venture further into space, establishing a human presence on the Moon and Mars, the issue of space debris will only become more critical. We must learn from our past mistakes and adopt a more responsible approach to space exploration. This means designing missions with debris mitigation in mind, developing and deploying active debris removal technologies, and fostering international cooperation to ensure a sustainable future in space. Our future in space depends on it. We have a responsibility to be good stewards of the space environment, not only for the sake of our own future endeavors, but also for the benefit of all humankind. Conclusion: ensuring a sustainable future among the stars. The issue of space debris is a stark reminder that our actions have consequences, even in the vastness of space. Each piece of debris, no matter how small, poses a significant threat to our satellites, space stations, and future missions. The silent threat of debris, a byproduct of our ambition to explore the cosmos, now challenges us to find solutions that ensure a sustainable future for space exploration. Engineers and scientists are tirelessly working to develop new technologies and strategies to mitigate this risk. By embracing sustainable space practices, developing innovative technologies, and fostering international cooperation, we can create a framework that not only addresses current issues but also prevents future problems. We can address this growing problem and ensure that the final frontier remains accessible for generations to come. Initiatives like space cleanup missions and debris capture mechanisms are already making a difference. The future of space exploration depends on our commitment to responsible stewardship of this shared resource. Every launch, every mission, and every piece of equipment must be designed with sustainability in mind. Let us rise to the challenge and ensure that our journey among the stars is not jeopardized by the debris of our past. Together, we can pave the way for a cleaner, safer, and more sustainable space environment.